Well, in the last video we made the sudden jump from just being able to compile a basic program into actually being able to compile and build dynamic link libraries and static libraries. I was going to demonstrate a fundamental difference between the static .a libraries and the dynamic .dll libraries. Once I've done that, I'm going to make a bit of a detour into compiler directives, but I'll explain why later. So, on with the difference between .dll libraries and .a static libraries. I'm going to revisit function 2, and I'm going to just change a little bit. I'm going to do grumpy papa, and then I'll save that. I've done make clean. When you do make clean, the make will see clean a list of dependencies which is completely blank, then a tab, and now rm. Okay, this is weird. That's a Linux remove command, the equivalent of delete, and that came as part of msys. In fact, if you type in delete here, because make is such a Unix thing or Linux thing that it won't recognize it, and what it'll do is just remove all your archives, executables, objects and DLLs. So I've done a make clean, then I went back and did make libhellostat and libhellodyna. So now we should have these DLLs, the libhellodyna imp.a and stuff, and there they all are. Okay, I've saved fun2 with grumpy papa. I'll do now make libhellodyna. You can see that the make facility has recompiled fun2.f, so we have a new object file to make libhellodyna. Of course, that's also built our import library as well as the DLL library. And now let's do make libhellostat. So we've got a new fun2.o that went into libhellostat, and a new fun2.o that went into libhellodyna. So let's do hellimp. Hellimp says grumpy papa. Let's do helldyna. Helldyna says grumpy papa too. And now do hellstat. Hellstat says dearest mama. Hellstat has not changed, has not picked up the change in fun2. So that's a fair big difference, isn't it? How can we get hellstat to pick it up? Well, what we have to do is just recompile hellstat. Let's do make hellstat. We tried to rebuild hellstat, but it told us that it's up to date. We then removed the executable and then did make hellstat. Okay, it's recompiled hellstat, and now when we run it, it actually sees the change in fun2. So unless you actually change hellstat.exe by recompiling it, it won't pick up the change in the library. The dynamic library, however, and that includes the import library that accesses the dynamic library. So when you type in hellodyna, it just goes and grabs the fun2 binary out of the library and uses it. it immediately picks up Grumpy Papa without recompiling HellDyna or HellImp. But HellStat has to be recompiled. This is one of the things that makes DLLs more attractive than archives. The other thing that makes them more attractive, DLLs, as I explained in the last video, are exactly the same as Linux and Unix shared objects, which means that lots of different processes can grab them at the same time. Static libraries, of course, they're actually built into the executables, so they don't have to be grabbed by anything at the same time. So that's the fundamental difference between static libraries and DLLs. So what's all this about compiler directives? Well, I need to talk about compiler directives because of this little thing that has to be sent to the linker by gfortran. It turns out that Intel Fortran and the Portland group Fortran don't really have an equivalent statement that you can send to the linker at all. Now you can see here I've made a couple of changes to the makefile. First of all, instead of being on one long line, I've used this backslash here to indicate that the following line is actually a continuation of this line. So we can split up that one long line into little bits. More importantly though, I've put in this minus output minus def equals libhellodyna.def. I've just executed that and I've looked at the file libhellodyna.def and you can see the word exports, fun1, fun2 and sub1. That means it's exported fun1, fun2 and sub1. I suppose the best way I can explain exporting is that these functions are made available to programs outside the DLL. So, for instance, these functions can be made available to the main program that calls fun1 and sub1. Well, we've gone back to the makefile. We've introduced these backslashes, which you can use to break up one long line into separate lines. But more important than that, the export all symbols has gone. Export all symbols turns out to be the default for gfortran anyway, so strictly speaking it wasn't necessary. But I've changed that to exclude all symbols. That's telling it not to export anything. On top of that, we've told it to output a definition file in this bit here, and there it is, libhellodyna.def. Let's just see what happens. Well, the first thing that happens is that it tells me something's wrong, and yes, there was something wrong. I'd forgotten the equals sign. Well, we can see what's happened here. First of all, we've successfully built the library with exclude all symbols and the output definition file. But when we try to make HellDLL, I've changed it from HellDyna to HellDLL, it tells us undefined reference to sub1, undefined reference to fun1. It doesn't know what on earth they are, even though we've linked it to the library. There it is, minus hell. And that's because it's not been exported from the library, neither fun1 or sub1. We can also see the definition file is just blank. There's nothing in it. Now, I mentioned that the Intel Fortran and the Portland group Fortran don't actually have this facility to export all symbols. So what do you do then? Well, you have to do it manually, and that means editing the library functions. Well, let's see what we've added to sub1.f. First of all, I have an exclamation mark in column 1, or first character if you like. Usually what follows the an exclamation mark here would be regarded as a comment. So for instance, if you did exclamation mark vote monster raving loony party, then the compiler would just regard that as a comment. Not a very helpful one to understanding the program, but the compiler would just skip it and move on. It would have no effect whatsoever. But with gfortran, if you follow that immediately by gcc $, all uppercase, it will immediately recognize that this is the beginning of a compiler directive, and what this directive does is it exports sub1 from the DLL. You can see the syntax. There is space, double colon, space, and then the subroutine name, or the function name. So I've done the same for fun1. There it is. Now the thing is, you need to also alter your calling program. Here's hello.f, that's the main program of course, and we have a compiler directive here with DLL import, not export, and then I've just got a list of what it's got to import, sub1 and fun1. I've built all that. Let's link it, and there you go, everything works fine. But before continuing, notice that there's no fun2. I haven't altered fun2.f in any way. I've only altered sub1 and fun1. See, the thing is, fun2 doesn't have to be exported. It's only called by fun1, and that's a function within the DLL. You only export stuff if it's needed by stuff outside the DLL. Now let's have a look. You can see that we have a list of exports, fun1 and sub1. We can just see that fun1 and sub1 are in our list of exports. When we did export all symbols, it exported fun2 as well, even though it didn't need to. So this is how we can export functions manually, by altering the source code of the library functions and the main program. Now if we were using the Intel or Portland group compilers, we would put in exclamation mark $. That's how these compilers recognize a compiler directive. However, if I try and build this now, the gfortran compiler will just ignore it because it doesn't have the exclamation mark GCC. So now finally we can move on to the next video, where we'll have a look at getting data in and out of the DLLs. Sorry about the delay.